Hello everyone! Today we are going to learn impulse and impulsive force in 15 minutes. By the end of this video, you should be able to communicate to explain impulse and impulsive force. To achieve these learning outcomes, I'll explain to you the definition of impulse and impulsive force, the effect of the time impact on the magnitude of the impulsive force, and the real-life applications involving impulsive force. Besides, you should also be able to solve the problems involving impulse and impulsive force. So, let's get started. Suppose, if you have ever kicked a ball or played sports that involve any kind of ball, you have been using the concept of impulse without even knowing it. So, what exactly is impulse and what does it have to do with any of those situations? Impulse can be defined as a change of momentum. The formula of impulse with the symbol of G is mv minus mu. We can also use the formula of G is equal to Ft, where F is an applied force and T is time of action of the force. Impulse has two different units, either kilogram meter per second or Newton second. What is impulsive force? Impulsive force is defined as the rate of change of momentum in a collision, or impact in a short period of time. The formula of impulsive force is mv minus mu divided by t, where mv minus mu is a change of momentum and t is the time impact. Just like an impulse, the impulsive force also has two different units, either kilogram meter per second square or Newton. What is the relationship between impulsive force and the time impact? Well, based on the equation, we can say that if a change of momentum is constant, then the impulsive force is inversely proportional to the time impact. It means that if t is small, then the magnitude of F is big, or vice versa. Now we have learned about impulse and impulsive force. Let's do an experiment. An egg drop experiment. I assure you this is going to be fun. Let's have a look at these figures. The first figure shows that an egg is dropped on the floor, while figure 2 shows that an egg is dropped on the mat. What do you think will happen to both eggs in figure 1 and 2? Do you think we can save the eggs? As we can see from this figure, the egg in figure 1 cracks once it hits the floor. When the egg is in the contact with the floor, the time impact is short, thus resulting in greater impulsive force. We can conclude that if the time impact is short, then the impulsive force is large based on the relationship between impulsive force and the time impact. Now, let's see what will happen to the egg in figure 2. Well, as we can see here, the egg does not crack once it hits the mat. When the egg is in contact with the mat, the time impacts become longer, thus resulting in a smaller impulsive force. We can also conclude that if the time impact is longer, then the impulsive force is small based on the relationship between impulsive force and time impact. And now, my friends, perhaps we can have boiled egg for breakfast today. Let's watch a short video of how golfers swing a bat. What is happening? What is the effect of using backswing while doing that? Here's the explanation. When the golf ball is hit by the player, it receives a sudden change in momentum, and this leads to a short impact time and the development of a large impulsive force. This helps the ball to advance in forward direction swiftly and also helps the ball to cover large distance. I'll show you another example. In this video, we can say that when a football player kicks a ball suddenly with force, the ball shoots away. When the ball is at rest, the velocity is zero. Hence, the momentum is also zero. After the force is exerted by the player, the momentum increases to a higher value due to development of velocity. This sudden change of momentum leads to the generation of an impulsive force. This impulsive force helps the ball to travel long distance in a short duration of time. Let's have a look at another example. From this picture, we can see that the long jumper athlete is bending his knees while jumping on the sand. Why he has to do so? What is the effect of doing it? Here's the explanation. The long jump pit is filled with sand to increase the impact time when the jumper lands on it. A jumper will bend his knees upon contacting the ground to cushion the impact on the body and to stop himself from falling backward. The action of bending his legs is to reduce the magnitude of the impulsive force acting on his body, making it safe for him to land without injury. Now we have seen the examples of impulsive force in real life. Do you notice that all the activities involve a pair of forces, action and reaction? The relationship between action and reaction is explained in Newton's third law of motion. Newton's third law of motion states that for every action, there is an equal and opposite reaction force. From this figure, when a boy steps off from the boat, the boy will move to the left, while the boat will move back to the right. From here, we can say that they are equal and opposite forces acting on the boy and the boat. The action force occurs when the boy's feet exert force on the boat, while reaction force occurs when the boat exerts a force on the boy's feet. Let's see examples of situations related to impulse and impulsive force. First situation is increasing the magnitude of impulse by follow-through action. This picture shows how the football player kicks a ball. From the picture, we can see that there are two types of force occur, action and reaction force. A follow-through action after a strong kick produces a large impulse. As a result, the ball experiences a large change in momentum and moves at a high velocity. The second situation is reducing impulsive force by extending impact time. From the picture above, collision caused a car to stop and experience a change in momentum. The crumple zone of the car extends the impact time during the collision. As a result, the magnitude of the impulsive force on the car is reduced. Let's move on with our third situation, increasing impulsive force by reducing impact time. You know that a pistol and motor are made of stone. A pistol moving at high velocity is stopped by a hot motor in a short interval of time, and this will produce a large impulsive force. This impulsive force can cause the object present in the motor to get crushed and break into smaller pieces. Let's move on with the application of impulsive force and how it helps in daily life. Have you noticed that the pot is breaking into two pieces? How is that possible? Well, a martial artist makes use of impulsive force to demonstrate his skills in a number of tricks. When a martial artist intends to break hard objects such as bricks or wooden planks by using his hands, he moves his hands swiftly and hits the object at a faster rate. By increasing the speed, the reaction times get significantly reduced and a huge magnitude impulsive force gets developed. This impulsive force is strong enough to break the hard objects into pieces. Now you know the secrets. Let's have a look at another great use of impulsive force. Have you ever been to the construction site? If yes, then maybe you have seen the pile driver. But do you know how it works? When the driver is made to drop on a pile, it experiences a sudden change in momentum. This gives rise to the development of an impulsive force. The impulsive force exists for a short duration of time, but has a high magnitude value. The impulsive force exerted on the pile drives it into the ground. Now we know how the pile driver can work efficiently by increasing the impulsive force. Let's continue with another example. Just now, my friends, we have done an interesting experiment by using eggs. Do you notice that the eggs is packed in a special carton? What is the purpose of packing it that way? Eggs are stored in a specially designed soft cardboard-like material. This helps in saving the eggs from coming in contact with any external force. The eggs are very delicate by nature. Even a short duration of force is strong enough to damage and break them. The cardboard increases the reaction time. Therefore, the impulsive force gets reduced automatically, thereby saving the eggs from being broken. Now, my friends, let's continue our lesson with second learning outcome: how to solve problems involving impulse and impulsive force. Let's take a look at this question. A 0.15 kg ball is moving at a speed of 40 meters per second when it is hit by a baseball bat. The ball rebounds at a speed 50 meters per second and its time of contact with the bat is 0.04 seconds. What is the impulsive force on the ball? Well, the first step in solving this question is that we need to list the given information in symbols. For mass, we can write it as m, which is 0.15 kg. For initial velocity, we can write as u, which is 40 meters per second. Final velocity as v, which is 50 meters per second, and the time impact as t, which is 0.04 seconds. The second step is to identify and write down the formula that we are going to use. As the question asking for an impulsive force, then the formula should be F is equal to mv minus mu divided by t. For the final part, as we need to substitute the numerical value and calculate to find the answer. The final answer shall be negative 337.5 Newton. Negative sign indicates that the ball moves in the opposite direction, which is to the right. Now, let's proceed with second question. The diagram shows a car with mass 3,500 kg, with velocity 15 meters per second, collides with a concrete wall. If the time taken for the collision is 0.003 seconds, calculate impulse and impulsive force. Given that mass m is equal to 3,500 kg, the initial velocity is 15 meters per second, and the time impact is 0.003 seconds, and from the question, the car stopped once collide. Therefore, the final velocity v is equal to 0. To solve the first question, we can use the formula of impulse, g is equal to mv minus mu. Then, we substitute the value and the final answer shall be negative 52,500 kg meter per second. The second one is to calculate the impulsive force. We can use the formula of F is equal to mv minus mu divided by t. Just substitute the value and the final answer is negative 1.75 times 10 to the power of 7 Newton. Let's have a quick summary of what we have learned today. In this lesson, we learned that impulse is defined as a change of momentum. The formula is G is equal to mv minus mu. Impulsive force is defined as the rate of change of momentum during a collision or an explosion in a short period of time. The formula of impulsive force is F is equal to mv minus mu divided by t. And there is always a pair of forces, action and reaction, involved in impulsive force. The shorter the time of impact, the greater the impulsive force and vice versa. Before we end this lesson, let's do some exercise to test your understanding on this topic. The first question is, can you spot any differences between impulse and impulsive force? Is there any similarity between those two? Second question, in a car collision test, a car of mass 1,500 kg hits the wall with a speed of 15 meters per second. The car bounced back with a speed of 2.6 meters per second. If the collision time is 0.15 seconds, calculate the impulse in the collision and impulsive force acting on the car. I believe you can answer the question. That's all from me. Thank you and have a nice day.